about DevSecOps today, and we're gonna talk about something nobody wants to enforce or implement or even think about, which is security. And we will think about the change of security in the last couple of years. And I think it's super important from both sides, from the developer side and from the operation side. So let's start. To talk about DevSecOps, we need to start with DevOps. And what is DevOps? DevOps is not something that you can install. It's not something you're implementing. DevOps is a shared responsibility model between the developers and the operators to push the code as fast as you can from code to production. That will obviously allow you to be more agile, to iterate faster, and to meet the business demands. Now, if we will take like a couple of years back, that wasn't the case. It was the left side case where you just take a binary, throw that on operations, and they are responsible for the production, for running it, for securing it, and everything else. Now, that, of course, can facilitate that iteration that you need. I can hear you. Can I? Okay. So if we want to inject now security into that DevOps side, it's the same shared responsibility model. So I'm usually, if we were in person and everybody was in the crowd, I was asking who's a developer, who's an operator, who's a network engineer, and who's a security engineer. And if you wouldn't raise your hand as a security engineer, that wasn't the right answer, because everybody has something to do with security. Everybody needs to be responsible for security and to inject security in each and every one of those steps. Continuous delivery, or CI/CD, continuous integration, and continuous delivery, that's the technology that will support that shared responsibility model. So the fact that you have a methodology and you have a shared responsibility model in your organization doesn't mean that it will be easy to implement. You need technology to support that, and that golden path to production that Cora mentioned allows you to stick to something which is consistent. Everybody knows exactly how the code should be going into production, what are the steps in that pipeline, and alongside of that, what are the security measures that are injected in each and every one of those steps. And we will get to that. But that's crucial for that. DevSecOps is the golden path and the continuous delivery pipelines. I don't have to say a lot about microservices, but I want to emphasize the change, because I think that's a huge parameter in the change of security landscape in the last couple of years. The break of a monolith to microservices basically changed everything that we know about securing a monolith. The reason is that even if I will take it like to an operational technical perspective, in a monolith, different services in the same OS was talking with RPC calls between like service and service, because it's in the same operating system. And now that it's microservices, they are talking over the network. So you need to think different about the way that you're securing each and every one of those components. And of course, the number of components that you will run in your organization are exponentially growing, which basically also create a new challenge and a new risk. Containers are not something new. We've changed the architecture of the application to microservices. We had to have something on the infrastructure side to support that. Containers are around since the Unix kernel, so it's around since the 50s, 60s. The reason we are talking about containers in the last 10 years, since Docker in 2013, is because we had to have an infrastructure component to support that microservice, which is a standalone, developed by the 12-factor development rules for microservices. And it has a lot of things, a lot of capabilities we want to leverage, we want to bring into our environment. And for that, we are using containers. From the operational side and from the security side, that's a whole new level and a whole new abstraction layer. When, like, I know I look young, but I'm old enough to remember the transition from physical to virtual. And when we moved from physical to virtual, we had to think about that virtual machine as a new entity in our environment. How do we connect that to the network? How do we back up that? How do we everything secure, of course, and create like connectivity and everything else? Now, containers, it shows exactly the same evolution, the same change, the same abstraction layer. It's another component in your environment, in your network. It has a different network stack, storage stack, compute stack, the way that you're connecting containers is not the same, the way that you're securing containers are not the same. So containers are the change that made like the operations and security needs to take in consideration when they get into microservices world. By 2025, more than 85% of the global organization will be running containerized applications. Of course, everybody knows that. I guess you know that already. The reason I have this slide is not because I want to convince you to go to containers and microservices. I think everybody is already convinced. The reason I have this slide is, again, to share the challenge and the risk of that layer being added into our organization. From physical to virtual, we had a ratio of about 30, 40 VMs into one physical machine, which means that when I wanted to secure that and connect that and manage that, I got like 30 times more components than what I had with physical. Now, each virtual machine will have 200, 300, 400 containers. Just do the math, right? The challenge and the risk of the numbers of components that will run in your organization means that you have to change the way that you think about security. You need to change the way you're architecting security. And I will get to that. You also need to change the way that you're enforcing security and policy and consistency on your organization. That's the analogy I have for the last, like, I don't know, 10 years between developers and operators and security. And of course, you know who's who, right? The developer is the road runner. He needs to run as fast as he can. He needs to get like things done. He needs to answer the business demand. And eventually his success is the business success. And he will run as fast as he can. Now, what happened when you put a barrier in front of the road runner? It will go around it. And that's what we saw in the last couple of years with security and microservices. We saw developers that needs to fulfill their assignment. And once they don't get what they need from the internal IT, from the internal organization, they just went around it. The concept of shadow IT was created because of business wanted to create business, and internal teams and internal organizations or policies or compliance or anything else just stop them fulfilling that assignment that they got to expand the business, to create new business line, new applications, or to go to the cloud or something like that. So it's not just enforcing security and injecting security, it's also meeting that developer where they are, or the developers where they are, and injecting security in the tools that will still allow that fast transition from code to production. And that's part of the shared responsibility model. So thinking on like the traditional way of security won't allow the developers to be as useful as they can or fulfill what they need to do and answer the business demand. I think you already know why developers love containers, but I will say that again. The reason is it's easy to just push the code and iterate as fast as you need. And just as an example, the Amazon page is being changed every 11.6 seconds. Now, I haven't seen that page down a lot, and they are changing a lot of different components simultaneously, a lot of different hosts. The reason they can do that is because they've architected the application according to microservices, best practices, and they are using those different golden paths into production that allows them to do that also in a secure fashion. Another thing is the ticketing system, and that's something which is painful in most organizations. If you're a developer and you want to push your code right now into production, you need to open a ticket. And then there's going to be an infrastructure engineer that will create a VM. There's going to be some DevOps engineer that will push something with configuration management to configure that VM. And then he will also need to configure the application runtime, and then he will push the code. And then you will have a web page of hello world. Fine. That took only 2, 3, 4 weeks, and you got the web page that you know that you could have done that like in 5 minutes. In containers, it's just one command because you're running kube control, run specific image, and that image has everything inside of that. Now, that's also where the difference between VMs and container images are super critical for security. Because in this case, you have a new path to production. You have a path to production that doesn't go through the ticketing system. It doesn't go through the governance of the current pipelines that you have. You have a developer that uses the golden path to production, which is great, and it pushes that image directly to the environment that it needs to run on. Development, test, pre-prod, or even production, depends on the organization. So the security measures are not after the effect, it's inside that pipeline, that container image creation, the build process, and the deployment process. So what about security? Well, security was left behind. And the reason for that is there's a couple of reasons why, but changing the security mindset and the security architecture isn't easy. For a long, long time, we had that notion of, a fortress. We are creating a perimeter and we are shielding everything from outside, and we don't have anything outside, right? We don't have a cloud or a public cloud. We have our on-premise environment. And if you came from the army, you don't even have any access to external networks, so it's even easier to create that fortress. Along the time, the different changes like the use of cloud, of public cloud, the use of microservices, the change of everything in the application architecture made that task of securing the workload really, really hard and challenging. So let's talk about like a bit about that container Kubernetes and security thing. 97% of organizations have concern about Kubernetes security. I would love to grab a coffee with the 3% that said, I don't care about it. But that's the fact, right? 97%, which is a lot, and everybody knows you need to do something, but what and how and when in the pipeline, right? Because that's the most critical thing, to have the business outcomes alongside the security outcomes that you need. We asked our customers what are the challenges in security, and the first thing they said is policy consistency. And it makes sense, right? If you're now going to use different public clouds and you're gonna use your on-prem and public cloud, and you're using different infrastructure providers, different policies or network stacks, now how do you get that one single policy that the organizations creates, and then how do you enforce that across everything? Kubernetes is amazing, right? Kubernetes is the most powerful API layer infrastructure ever created, but it's also that abstraction and that openness is also a risk. And the way that you need to be like the only way you can actually control that is by consistently deploy and enforce policies across everything. The second thing is the workload at runtime. There's a different running workload aspect between VMs and containers, and that's obvious, right? A VM will run probably containers on top of it, but it's also the way that you're creating that workload and running that workload. So when you talk about workload runtime security, we've started with endpoint security, which was just the endpoint, like your PC or your Mac. And then once servers became something that can run not just in your own environment, we had to create workload security for servers. Servers are running differently from endpoints. They don't change a lot. You know exactly what should run on them, and you can anticipate the behavior. So workload security became a thing. But now when you have containers that are running on VMs, now containers needs to have that kind of you need to address that layer of containers and what's running inside the containers, because the container also has an OS, an application runtime, an application code, and everything else inside of that. So that's number two, and I think that's super critical and important. Securing container images in the CI/CD pipeline, that's where you can take and leverage of like architecture to inject security as soon as you can. Now, the reason you do that or shift left security, I've talked a bit about like a cloud native application protection platform. Let's talk about it again. It's basically the most comprehensive framework of security for cloud and cloud native today in the market. It's from Gartner. You can check it out in the Gartner website. To summarize things, it's divided into three pillars: artifact scanning, cloud configuration, and runtime protection. The artifact scanning represents the shift left or the left side of the pipeline, where you scan your code, scan your image, making sure that the static analysis is right, dynamic analysis with inputs are right, and there's no vulnerabilities there. Starting your API scanning and your API security from that beginning of like the creation of the workload, and then going into like the middle pillar of the cloud configuration. Cloud configuration is super important because you're creating that basic landing zone. If you're creating that correctly, then you can build your buildings on top of it. So Infrastructure as code scanning as part of the configuration management scanning and scripts and everything else. Entitlement management, making sure that you don't have excessive permissions, not for machines or humans to do things that they don't have to. Kubernetes security posture management, or KSPM, that's part of the hardening of Kubernetes. As I said, Kubernetes will run exactly the same across any infrastructure provider. So we need to make sure it's hardened and the security posture is exactly the same and secured across any Kubernetes cluster. And cloud security posture management, that's CSPM, that allows you to basically make sure that the configuration of the cloud is against best practices, the security posture is consistent and secure. On the runtime side, when you have that runtime running, one crucial thing is API protection. And the reason is everything is API driven, everything is like API to API connectivity. So if you're securing your API correctly and you know exactly what's running, how it should run, how it should communicate between the different components, you can also harden that and you can make sure you can restrict any communication just for the one that you know should be there. Application monitoring is another aspect of the operation side, but it has a lot of security aspects. If you're monitoring your security and user experience and latency and everything else, different diversion of the behavior that you expect may indicate also security issue or security vulnerability. So application monitoring is super critical, or observability and everything else. Cloud workload protection platform, that's the essence of like the workload security. When I've talked about like the VM security or the Linux OS, then you have a container inside of that, which also has an OS by itself and application dependencies, application runtime, and other services. So cloud workload protection platform, in this case, in the runtime protection, think about an agent or an antivirus or next generation antivirus or workload security. That's an evolution of the different things. And it's mostly around detect and response. So when there's everything detect and response, or um, NDR for the network, XDR for everything, and so on and so forth. And those different tools will allow you to make sure that if there is anything, you're getting that event, and then you're also responding to that event or vulnerability or explosion or whatever. Network segmentation, that's where, again, when you talk about network segmentation, we have different layers. You have network segmentation on the physical layer. If you have on-premise environment, in the cloud, you will have software-defined network with network segmentation on that network-defined software-defined network stack. But then if you want to get into an abstraction layer where you have connectivity and security across anything, you have to elevate networking into the application level, use service mesh or API security, or there's a lot of different ways to do that, but basically create policies of connectivity between the APIs, no matter where they are running. So the same API endpoint can run on one cloud or the other, but the policy will stay the same, and the access or the restriction will be the same across any cloud. The last bit is exactly the same bit that you had in the artifact scanning, which is exposure scanning. As a security persona, it doesn't really matter what are you doing in your pipeline or on the cloud. When it's running, I'm going to scan everything again. So even if you scan the code and the image on the pipeline, when it's running, I will continuously scanning that image to see if there's new vulnerabilities that was detected. I will scan for or check for the security posture of Kubernetes in the runtime, check if anyone did a mistake and created a secret which is not aligned with my policy of the organization, and attack path analysis and everything else. I will just scan everything again. When we get into like thinking about CWPP, 5Cs, Salsa, and everything else, everything is basically converged inside that CNAPP, inside that Cloud Native Application Protection Platform. And that's also the reason I'm saying focus on that. It's an industry standard. It's led by Gartner, and it has the most comprehensive landscape of security from code into production. You see Salsa is on the left side, code, container, cluster, and cloud are divided between the pillars, and then you have connectivity and runtime, and cloud workload protection platform is part of the cloud native application protection platform. Security culture and methods needs to evolve. Like, it doesn't really matter which technology you will have, doesn't really matter how many tools you will have or how much money you will spend. If you won't change that shared responsibility model, and if it's not going to be part of the responsibility of each and every one of the people that has something to do with that pipeline or with that path to production, um, nothing will change or nothing will be implemented correctly, right? The security culture and the methodology of that shared responsibility is the first thing you need to work on, and then pick and choose the technology that will support you on that journey. On the secure supply chain, I'm gonna go through like the supply chain, just summarizing everything that we've just been through. And of course, as part of that, we will get into like different tools that you can choose. I haven't said a lot about VMware or about Tanzu. I will talk about it a bit in the next couple of slides. But the main like goal for me in this presentation was to talk about the DevSecOps approach, the change that you need to think about, and the way that you have to change also the way the internal processes and the internal methodology that you're working on right now on security side. So if I'm taking that pipeline or the DevSecOps, the VMware way, it always starts with the code, and that's the left side. If you're doing things right, and you probably are if you're listening to me right now, you're using Spring as a framework. Using a developer framework will allow you to also secure everything because everything is pre-configured with like the right dependencies or the right structure, and it's community driven. Everybody can take a look on that. You can be sure that it's not something that someone just copied and pasted from Stack Overflow and something is injected in that code. So using a framework, that's the first thing. Then scan the code, make sure that the dependencies that you choose was the right ones or the most secure ones. And if not, and if you have to use something which is all because of different like reasons, at least you will know what the CVEs are and what the vulnerabilities are, and then try to mitigate them along the way. So it's not a perfect world. It will never be a perfect world. There's always going to be reasons why you can't use the latest and greatest dependencies and code and layers and everything else. And that's fine. But you just need to make sure that you manage the risk along that pipeline. And if you can't mitigate in the code and in the build, mitigate in the runtime or mitigate in some other way. And you can, right? You always have the options to mitigate and reduce the risk along that pipeline. So the first thing is scan the source, scan the code, and also sign it. So that's another important thing. The integrity of the code is super important. Make sure that if you're managing that code in a repository, you're also signing that code before building it so you know that what's built is exactly what was coded. Start a secure supply chain, start that with the build. Do that in a secured way. If you're using buildpacks.io and Paquito, that service or the Tanzu build service will allow you to take the code, attach the most secure dependencies, and to create a secure build, which still gonna have vulnerabilities, and that's why you need to scan that image as well. But it will have less vulnerabilities than other ways to build that code, and it will have also the consistency of every build will have exactly the same OS dependencies and so on and so forth. And consistency matters. Again, even if you need to mitigate some vulnerability, if you were consistent in creating those images, it's always going to be the same vulnerability on all of the images that you need to mitigate. So then you can think like in an organizational way, how do you mitigate a vulnerability that every workload has, and not just one or two or 1,000 snowflakes that are now running with different OSs, different dependencies, and different ways to build. So that's the build service. Then scan the image, make sure that you know the vulnerabilities and how to cope with them. If you decide to keep going, that's where you're pushing that into a container registry. Now, of course, that container registry has more than just what you've built. More than, and again, those are numbers, but it depends on the organizations. But you have a lot of different off-the-shelf application that you're pushing into that container registry that wasn't built as part of your build process. So you need to make sure those other images are also secured. How do you do that? The first thing you can do is use an external OSS packages from a legitimate source. And if you can, also create your own application catalog. So inside the Tanzu portfolio, we have the Tanzu application catalog, which is Bitnami in the past. All the open source projects inside of that are secured by design, signed and managed and supported by VMware or by Bitnami. And it's not just us, right? If you will go now to AWS and you will try to consume Redis, take a look on the publisher. The publisher is Bitnami. And what you can do with Tanzu application platform is to create in your own environment exactly the same application catalog that you have in AWS, Azure, or whatever, but it's something that you're controlling and you're managing, and you also get support from VMware. Either way, all of those images will get into the same image registry. So if you're doing security right, you have one image registry, and that's the junction of everything that comes into and then everything that comes out to, right? So on the deployment, when you get into that deployment, you will again scan everything in the registry, make sure that you have the CVEs, and then keep going into the deployment phase. The next step will be to create a manifest to deploy that image. If you're doing that with a pipeline or with a platform, the platform will do that for you. If you're not, you've already created something like an Helm chart or a Carvel package or an operator or a YAML file or a JSON file. You need to make sure that it's against your policy, that all the different configuration in that manifest are aligned with your security policies of the organization. So that's where we're getting into like the hardening of Kubernetes or making sure that Kubernetes is configured correctly. And that's where it's also gonna, like the part of KSPM, Kubernetes Security Posture Management, gets in this exact part. You can scan those manifests before even running them. So think about the different steps we went through even before running anything in our organization. That's exactly reducing the attack surface as much as you can before even getting into Kubernetes. So when you get into that step, you can scan the manifest, and if it's not aligned with your Kubernetes security posture policy, you can stop the deployment there. If you decided to keep going, then you will actually go into the Kubernetes cluster. So you will try to deploy that Kubernetes workload on a Kubernetes cluster. And then you have the last gatekeeper, right? You have the last admission controller that will check for the same configurations of Kubernetes. And if it's not right, it will stop before even running. So you have a lot of different checkpoints, a lot of different control points, and you can stop the progression or the deployment in each and every one of them. When you get into the runtime, now you have a workload running. Everything about the workload security comes into effect. You need to think about workload security from within the container, from without the container, so the host security, the container security, and you need to think about everything that happened before. You need to scan the image continuously. You need to scan the security posture of Kubernetes. And in this case, in the application runtime, you also need to think about the cloud runtime security and the security posture of the cloud. And if you think about it, that's also code container cluster and runtime. So code container cluster and connectivity. And we will get into like the next one, but the 4 C's, when you divide that into layers and you do that pipeline right, you are going through those 4 C's. And now you can see also the 4 C's. So that's the cloud underneath, and the connectivity, that's the 5th C, and that I'm always adding. So the last thing is how Tanzu helps you with that. And to be honest, in each and every one of those steps, you have something of Tanzu that allows you to secure your pipeline and your platform. And from the cloud security posture management, the cloud security cost management, guardrails on the cloud level. If you go up to the OS, we have our own distribution of security for workloads and containers. Go up to the Kubernetes runtime, we are able to apply KSPM, Kubernetes Security Posture Management, with all the different security configuration on the Kubernetes side. On the networking side, we can elevate your network into a service mesh level, which allows you to create that connectivity and security on the application level, not just on the cloud level, and that's another abstraction. and the entire pipeline itself, which is the Tanzu application platform that allows you to take your code, use Golden Path, push that into production, and be secured across the entire way. Summarizing everything, basically the only thing you need to remember from this presentation is continuously secure everything. You need to always make sure that your cloud is secured with cloud guardrails, CSPM, KSPM, CIEM, attack path analysis, and policy drifts. All of the things that we've talked about in the middle pillar of the framework of cloud native application protection platform. You need to continuously enforce that against your runtime, and the runtime is the SecOps in the middle, where you have workload security, network security. You need to secure the host, the API layer, and continuously scan your artifacts. And then if you go to the back in the pipeline, you need to secure your builds, supply chains, artifact scannings, and basically secure the app. So secure the app, secure the run, and secure the cloud, and make sure that it's always continuous. So the connection between the runtime and the developer, and the feedback loop from runtime vulnerability into the developer to make a change, and then back into the runtime, continuously scan that, and again and again. That's the key. Another key that we've talked about, and that's the last point, is because of that architectural design of cloud native and microservices, you can make sure that everything is declarable and you're running everything against the desired state. If the cloud is configured by a desired state, if your application and code are configured by a desired state, and your runtime is configured by a desired state, it's easier to secure because you know exactly what was built and what's running, and you can make sure that it's aligned. And yeah, that's it. I hope it was useful.